Yeah, so welcome to video 2. So we will start scaffolding our project. So we create a directory and we name it log service. Then we cd into log service and we open Goland here. So what do we want to do? Let's create a CMD directory, and then inside the CMD, that's where our main.go file will live. So to make sure it's working, everything is working, let's write the main function. Then we do go run cmd main.go. Yeah, we get an output. So what do I do with a new Go project? So I will create a makefile. And then inside our makefile, we will create all that. So what do we have here? So we have a way of building our project. If we'll have test, this is a way we will test. This one is a helper function that will help us to generate logs. Then we start our ZooKeeper. I've installed it in tools directory in my computer. Then how to stop ZooKeeper. Then the ZooKeeper client. And then how to run the application. So conform with that, I think I'll need a node directory here, and then our main.go file goes inside the node. So when we run make run, we get hello logs. When we run make build, a go mod file was not found. So we will do go mod init distributed log service. We call it like that. Then we do a go mod tidy. And then when we run make build, so we don't have a client, so the bin directory is created. We do /bin /node, we get hello logs. So what will we need? So the nodes will need a way to discover each other. We will need the app folder where we wire everything together, a cluster coordinator, the models and all that. So let me just start by creating an internal directory. So we'll do make directory internal. Yeah, so make directory internal, and then we can cd inside the internal directory and then create its child directories. So we'll need one called app, we will need one called the cluster, we'll need one called the log. So that is where our parsers will go, our data models for the logs will go. We'll need one, I named it networking. And then we'll need one for the model, and then maybe scripts for testing. But let's just create scripts that will help us in testing. And so on and so forth. So what are we going to start with? I think I'm going to start with the model. So no, we don't have that yet. So this will carry our data models, all our structs. So because we are dealing with logs, we will need a log entry .go file. What will exist in, what will our log entry have? So we'll need a type. We'll name it at log level, and it will be of type string. So what will this represent? It will represent severity of the log. Uh, that's not the spelling. That's not the spelling. Or not severity, but severity. Yeah, English is not my first language, so we'll define constants. Which will be log level debug, log level info, log level 1, log level errors, then log level fatal. So we'll need all that. And then instantiate variables for allowed log level. So this is just will help our code in verifying if the log level that is ingested is valid or not, and stuff like that. So We'll name it valid log levels, and it will be a list of these log levels. Yeah. So we'll create a function, a helper function, and we'll call it is valid log level. That will take a log level and return a boolean. So we should return the true. Yeah. Else, oh no. Yeah. Else we return false. So how are we going to represent a single log entry? So we'll need a type. Level will be one of our log level. Message will be a string. Let's have JSON annotations to them because they will be marshaled and they'll travel over network. So each log will have a log group. Will be of type string, message, and then a log stream, just like we see on CloudWatch. So yeah, just like we see on CloudWatch. So and then the log, we have level, message, log group, log stream. Oh, each timestamp, we'll need a timestamp. And then structured fields. It can be map string interface would be the best to have, but for simplicity, let's just have it as a map of string. Yeah. So we'll have a function to validate if a log stream is a valid log stream before we ingest. Yeah, because we are going to keep these logs. Maybe even we will extend this so that the metadata of the logs are kept in maybe a Postgres database somewhere or something like that. So to validate that what you are ingesting is a valid log entry, we will have this helper function validate that will return error. So each log entry should have log group and a log stream. So we are going to look at the two things. So if yeah, also let's check on the suggestion log level. So we were provided with if e dot, if the log group is, let's just return validation failed, log group is required. Let's Yeah, so that will be our helper function to validate log entry. Then we will need, let's see what's throwing an error here. Oh, we need to return nil. Yeah, so that's that. Let's have a serializer. And what will our serializer do? We'll serialize and deserialize the log. So since we have the JSON annotations, we'll just use encoding.json. So we'll have a function that will take v of an interface and return bytes and errors. So what will we return? Return JSON.marshall. Yeah, so these are just helper functions. On the JSON.encoding, because we can just call this directly on the struct, and we will get the same results. So we will also have we'll need to Marshall indent. I think we just need Marshall here, and then we just give it the log entries. And then deserialize log entry on Marshall. Now here we need a pointer to entries. Return. Slice an array of log entries. So when we send a query, we also need to, let's see, did we define a query? No. So when sending a query, we will need to serialize the query and deserialize it. So let's make a function serialize query. It will take the pointer to query. Then what does it return? So let's define the query. How does the query look like? Query is a structure that has the timestamp, start timestamp, end timestamp, because we will be querying these logs like normally the way you query logs from a start time to an end time. You query by levels. If you know the exact log group that you want to query, you put it in the query. If you know the exact log stream, if you know a word that should appear inside the log, like message contains, if you can filter by fields, and then we'll have a limit. How many entries do you want returned to your client when you do the query? So this is what query this is what a query like structure looks like. So we will need a query response also. So when you do the when you do when you send the, the query request, what do you get as a response? So you'll get a list of entries, total count of matching entries, query duration, how long it took, the number of scanned entries, and then any warning if workers timed out, if anything happened to a worker while you are doing the exact query. So that's that. Our query. We will also do some ingestion. So for a query to be valid, what do we need? Let's deal with that first. I don't know if I should put it down here or here, but we need a helper function. Query validate. So it must have a start and end time. And the start time should be greater than the end time should be greater than the start time. Like you can't do a reverse, like yeah. I think you get what I'm saying. So how do we validate that? We start by if q.start time equals to 0. We return start time is required. if you dot if everything happens well, return nil. So that is how we validate that. And we'll need an as was shown in the demo, we have another. We have the ingest endpoint. We have the query endpoint, ingest endpoint. So we'll create structure for that. So type ingest response. Field called count, which is int, and then error. So if error occurs in a worker while it's doing the ingestion, so we need another structure, ingest request. They will contain log entries, just like we can see here. And then ingest response, ingest request, I think would be above this. Yeah, so request, response, query response, query request, query response. Let's move all these helper functions to the bottom of the file. Query request, query response, worker request, ingest request, response. What else do we need? So each worker will be doing work. So we will send an index. Search these logs, but start from here. So then the response will come with the log entries that it looked at and the scanned entries, like the entries it found and the scanned entries it looked at. This will be returned to the coordinator. Then the coordinator will compile the list that now is sent to the client. So I intended for this to be 1 hour long. So let me just check how many hours have we? Oh, we've been going for 30 minutes. 30 minutes to go. So I hope I'll be done with this one package. So so the coordinator sends the worker's requests. And then the worker sends the response back. Let me create structures for those. So type request have query, which is of type query, and then the worker index is integer. So total workers in the pool, and then that will return as worker query response, which will contain the log entries, and then the scanned entries. So that particular worker, how many log entries did it? So I think that's that for this. So just a recap, we need the models for serialization, the query, log entry, and so on and so forth. So I think we can wire up the server or and create the handlers inside networking. Let's create this is a directory. Let's create a file, and then we will just have the handler interface. Let's name it request handler interface. It will have how many methods? Handle request, which will take a payload. Bytes. And we'll just return slice of bytes, byte, then get endpoint, which will return string. So inside here we'll have a max handler. What will we have inside the max handler? Let's have a mutex think .rw, read write mutex, and then we'll have roots, which will be map of request handler. So and have HTTP function. Then we path, which is up of things. How do we construct a new max handler? We'll return a max handler, then routes that Then path. Oh, path should be a map. Map tray bool. Then we need a method to register a route. Marks handler. You do a lock and then defer that lock. We have a key b method code class and empty string plus path. H truth equals to handler equals to true path. Then we don't want to defer that there. R dot method plus the r.url path. we will need a helper function for the recover middleware. Then if path exists, error not found, and we return. Here we'll use zero log follow. Go mode tidy. That's okay. So that is done. We'll need the client. So yeah, the stream is getting long. So I will build this, or we'll continue in the next stream. So thank you for staying around. Thank you for watching if you watched up to this point, and see you next time.